Hey, Ms. Rivera, I've got this problem about a right triangle with legs of length 9 centimeters and 12 centimeters, and it wants me to find the length of the hypotenuse. I feel like the answer should be a nice, whole number, but I can't quite figure out how to calculate it. Where do I even begin with showing the steps for this?
Nice problem, Cody. You're right. When you're given the legs of a right triangle and asked to find the hypotenuse, there's a very famous theorem that connects those three sides and often leads to the nice whole numbers you're thinking of. You've already identified our inputs. The two legs are 9 centimeters and 12 centimeters, and our goal is to find the hypotenuse. What mathematical relationship or theorem comes to mind when you think about the sides of a right triangle?
I think it's the Pythagorean theorem. I remember it has something to do with A, B, and C. Is it like a squared plus B squared equals C, where C is the hypotenuse?
You're absolutely right, Cody. The Pythagorean theorem is exactly what we need here, and you're correct that C represents the hypotenuse. You mentioned a squared plus B squared equals C. Can you make a small adjustment to that last part, remembering that all three sides are related by squaring?
Oh, right. It's a squared plus B squared equals C squared. I knew it had to be all squared. So, if A and B are the legs, I just need to plug in the numbers, right?
Excellent, Cody. That's the correct form of the Pythagorean theorem. A squared plus B squared equals C squared. You've correctly identified that A and B are the lengths of the legs. Now, what would that equation look like when you plug in the lengths of 9 centimeters and 12 centimeters for the legs?
Okay, so it would be 9 squared plus 12 squared equals C squared. Let's see. 9 squared is 81, and 12 squared is 144. So 81 plus 144. I think that's 215. So 215 equals C squared. Does that seem right?
You're off to a great start, Cody. You correctly set up the equation as 9 squared plus 12 squared equals C squared, and you've accurately squared 9 to get 81 and 12 to get 144. Those parts are perfect. Now, let's just double-check that final addition. What do you get when you add 81 and 144 together again?
Okay, let me try that addition again. 81 plus 144, that's 225. My bad. So it's 225 equals C squared. Now I need to find C, right?
Excellent catch, Cody. 81 plus 144 is indeed 225. So you have 225 equals C squared, and you're absolutely right. The next step is to find the value of C. How do you typically undo a square to find the original number?
To get rid of the square, do I just divide 225 by 2? So C would be like 112.5? I'm not sure if that's right for undoing a square.
That's a good thought about dividing to undo an operation, Cody, but when we have something squared, like C squared, the inverse operation isn't division by 2. Think about what operation is the opposite of squaring a number. For example, if we know 3 squared equals 9, how would you go from 9 back to 3?
Oh, I remember. To undo a square, you take the square root. So I need to find the square root of 225 to get C. Let me try that. The square root of 225 is 15. So C is 15 centimeters. Is that it?
Yes, that's exactly right, Cody. To undo C squared, you take the square root of both sides, and the square root of 225 is indeed 15. So the length of the hypotenuse, C, is 15 centimeters. Congratulations, you've solved the problem.
Awesome. Thanks so much, Ms. Rivera. I knew it felt like it should be a whole number, and 15 centimeters makes sense. I definitely needed a refresher on how to correctly undo the squaring to find C. I feel much better about this now.